Okay, tonight we're going to talk about the basics of data compression. And when I say the basics, I mean more from an operational standpoint, really more from setting it up and implementing it more than I do, how SQL actually does the compression itself and everything. That's really one of Paul Tripp's discussions. So I'll leave that to him. He does that so much better. Maybe I'll plagiarize it for you one day, but I would only be plagiarizing it. So anyway, we're going to start here. We've got two tables. This one's compressed already, and this one isn't. And what I'm going to do is I'm going to walk you through the compression wizard because it's really the easiest way. And if you want to write code, then I'll show you the best way to do that here in a minute. But all you got to do is you got to right-click on your table. Mine is Big 3, and you go to Storage and Manage Compression. And you see here, it comes up right away. It shows you that the compression type is none. And you got two types. You've got row level and page level. We're going to do page level for now. And all of this boundary and partition, see, that's the boundary, that's for the partition column, but this is a single partition table. And you're going to come down here, and first you're going to hit calculate, because what you really want to do before you do this is find out if it's even going to be worth your time. And while that's doing that, I'm going to discuss just a little bit. There's an awful lot to compression, and there it returned. There's an awful lot to compression. All types of rules when it comes to reindexing and inserting and bulk loading and managing replication and indexes and whatnot. So, all of that stuff is beyond the scope of this discussion. This is just going to be a basic. Here's what compression is. Here's how to turn it on. Here's how to do what you need to do. Right. And I'll leave that other stuff maybe for another video. And okay, sorry, got distracted there for a second. Okay, so we've got our compression on our table calculated. Now, if you look here, it doesn't really tell you what percentage your increase is. You've got a row count, and you've got current space, and you've got requested compressed space, right? It doesn't really tell you what that is. So what we do here is we pull out our trusty calculator, and we take 1020 789 and then divide that by 1928 719 and then multiply that by 100. Okay, so you got 52. So that is 52% of the compressed value is 52% of the current space. But that's what percentage it is of the space. To get the percentage of compression, you still need to subtract that from 100. So now I say minus 100. And then we get 47% compression. So yeah, this one compressed 47%. That's not actually too bad. I've got a table at work that I compressed, and it's got, 200-300 million rows in it, and it compressed almost 80%. It's a very poorly managed table space-wise, and it compressed really, really well. Probably has a lot of duplicates in it too, right? This one is just some generated data that I threw together just for this, and it's literally just thrown together. So, it doesn't compress nearly as well. And I've got another table in another database that compresses about 13 to 15%. So, it's all over the board. So by all means, test your own compression level and don't go by mine at all. 47% is pretty good, but I've seen the compression do so much better. But if your data doesn't support it, it doesn't support it. I mean, that's all there is to it, right? And some other time we'll talk about what actually goes, how you can increase your compression level. We'll talk about some things you could do to your data to increase your compression level. But for right now, again, that's outside of the scope of what we're doing here. So, okay, so we've got our compression level. And actually, before I finish this wizard, I want to show you, I'm going to cancel out of that. I want to show you how to go do this elsewise. So here, there's an SP that you can use to do the same thing. SP, estimate data compression savings. And then you pass it in these variables. This is the schema, the table name, this will be your index ID, and this will be your partition number, and then the type of compression that you want to do. Let's do page. So obviously these two are null because I'm not doing an index, and it's a single partition table, so you don't need to put the partition there. So that will run this. It'll only take a couple seconds. Okay, more than a couple, but still. Okay, and it's back. So we get all this information back, right? And we get the size with the compression setting, size with the requested compression setting, so with the current and the requested. And then one thing we get here that we don't get in the wizard is we get the sample size. And I really like that because I like to see how much of my data it went against, right? So you do the exact same thing. Here, actually, let me pull so I can see both of them. There it is. So for here, I'm going to say 404.56 divided by 1975008 equals 0.02. Then you multiply that by 100, right, to get your percentage. And so it sampled 2% of my data, which, you know, Microsoft says is the official word from Microsoft is it's statistically significant, is the phrase they banter around. So, and it is. I mean, if you look at it, the times that I've done my actual compression based off of the calculations here, I've been within, depending on the data set, between 1 and 3% accurate from their estimate to what I was actually getting when the table was compressed. So 1 to 3% accuracy, or 1 to 3% standard deviation, that's actually not too bad. I'll take that. That's why it's called an estimate, right? But what it does when it does this estimation is it actually takes that 2% of your data, and I don't think it's always 2%. I'd have to do it for every single table I ever compress, but it's a small amount. But what it does is it takes that percentage of that data, that small amount of data, and it actually compresses it in memory and then measures the size. So it's not like it's trying to do some kind of funny math to estimate it. It's actually doing the compression on a smaller portion of your data and then giving you the numbers. So that's how they get it to be so accurate. Anyway, so that's how you do that by hand to estimate that. Now you notice how this doesn't actually give you a way to compress the table. It just allows you to estimate the cost. Okay, so now to come back here and go back to storage and here, so we're going to finish up what we started here. So I'm back in the wizard. We go to page. I don't need to calculate because I already did that. Now right here, this is my favorite way to script this, because it says here, create script, run immediately, blah blah blah, script in new window. Well, yeah, I want to create the script, so I'm just going to hit finish. And there we go. And of course we get an alter table, data compression equals page. It's that simple. So now I'm going to run this. Oops. Yeah, it's got a use statement there. So I'm going to run this, and I'm going to let it go. And this is going to take a few minutes, probably not too long. But I'm going to pause it all the same. And now that I've got it going, I'm going to go ahead and pause it, and then I'll come back when it's finished. Okay, now one thing I forgot to show you here real quick, while we're doing this, it's still going, is that you can check this value. You can check how your compression's doing here. If you select from sysperfinfo, where the counter name is like compressed. There's only two of these. Only two of these guys. Are we still compressing? Yep. So from doing that, you see how the counter value is 2948364, and you got 2964774. So you can see the compression pages, the compression attempts per second, and the pages compressed per second. So you can keep an eye on how your compression methods are progressing by doing this. And did I already say that you could do it through Perfmon as well? Yeah, because these are just a window into Perfmon, right? So anyway, while that's compressing, I just wanted to throw that out there. Let me see, and that's still going. Okay, I'm going to pause it again. Okay, it finished up here in about 5 minutes, and that's actually not too bad considering this isn't a really big server. It's only got 1 gig of RAM, and it's got plenty of disk, but it's only got 1 gig of RAM, and it's only got like 2 CPUs, I think. So, and it's compressing in the neighborhood of 17 million and change. So it's not a small table. It's not really wide. Here, I'll show you what the table looks like just just in case you're that curious. There you go. That's what the table looks like, and it's generated data, and this is these are filled up pretty well. So anyway, yeah, and it's 17 million and change, so it's not too bad. Now, one thing I forgot to show you earlier was when a table's already compressed. When you come in here, you can tell that a table's compressed in the wizard because it comes up with the compression type. I don't know if you remember, but before it came up with none. And so here I would imagine that you could decompress it this way as well. You calculate it and you're going to say, and you should see the current space and then the requested space should be greater this time because you're asking it to explode now instead of compress. So we'll just give that here a minute to finish calculating. There we go. See? So it's going from 1008 to 1916. So not too bad. And then you would just hit next, create script, and then you see that all it does is set the data compression back to none. So, you know, doing that is pretty easy as well. So anyway, like I said, compression, there are a lot of things to look out for, a lot of caveats in there. So definitely do your research on compression itself, then do your research on your data and whether or not your system can handle the compression. Don't just implement compression wildly. I really advise against that. You're gonna get yourself in trouble. And if you move data from one server to another, like for a test system, you know, you've got your production system, you're going to move your data over to a test system, you know, make sure you test compression on the other side as well, because if you've, you know, if one of the big caveats, if the data is in a different clustered order, then you could drastically change your compression level and you might not be able to fit all of your data on disk. That would fall under the heading of one of those things I said I wasn't going to talk about tonight. So I'll go ahead and stop here, and good luck.